So let's take a look and work down through these problems. So one of the first things we want to do is we want to make sure that we understand the naming system from before. So with this we have mercury, which is Hg. It's mercury 2, which means it has a positive 2 charge. And it's with sulfate. Sulfate has a negative 2 charge. So that right there is going to get that for us. So we determine the molar mass of mercury 2 sulfate by adding up mercury, which is 200.59, plus the 32.06 for the sulfur, and then 4 times 16 for the oxygen. 200.59 plus 32.06 plus 14, 200.59 plus 32.06 plus 4 times 16.
It's 296.65.
296.65. Is enough. So now we're going to use that for the total down here for all three of these. So we want to find the percent composition. Remember, percent composition is part over total. So we have the total for all these as being 296.65. We're then going to put the part of each of these above it. So the part that was mercury is 200.59. The part that was sulfur was 32.06. 4 times 16.
The answer is 64.
The part that is oxygen is 64. 64 divided by 296.65 times 100.
The answer is about 21.5742.
21.57%. I'm going to rewrite that just so it looks better. Maybe. 21.57. 32.06 divided by 296.65 times 100.
The answer is about 10.8073.
It's 10.81. 200.59 divided by 296.65 times 100.
The answer is about 67.6184.
A good check for this is to add all these up and see if it adds up to 100. 67.62 plus 10.81 plus 21.57.
It's 100.
So there we go. Remember, tomorrow you may want to have some scrap paper ready for you while you take the test. That way you can write all these things out like this quite easily. How many copper atoms are in 18.5 grams of copper? 18.5 grams of Cu. So we have grams of copper, so we know grams is going to go on bottom. And from the periodic table of elements, every 63.55 grams of copper is 1 mole. They don't want moles of copper, they want atoms of copper. That's no problem. Because every 1 mole of copper is 6.02 times 10 to the 23rd atoms of copper. For this, we do need our calculator, because we got to use scientific notation. 1.85 divided by 63.55 times 6.02 times 10 to the 23rd. It's going to be 1.75. We're going to have the same number of significant digits as this number right here. So 1.75 times 10 to the 22nd copper atoms. It makes sense because it's not even a mole of copper atoms because we have less than the 63.55 required grams. How many moles of magnesium acetate are in 35.50 grams of magnesium acetate? So again, we start with what they give us, 35.50 grams of magnesium acetate. Every so many grams of magnesium acetate. So at this point, we have the grams of magnesium acetate up here. So we need to go to the periodic table and find the mass, what we call the molar mass of this. So we have 4 carbon, 6 hydrogen, and 4 oxygen. 4 times 12.01 plus 4 times 16 plus 6.06.
That would be 118.1.
Oh, we got to add that to the magnesium, don't we? 4 times 12.01 plus 6.06 plus 4 times 16 plus 24.31.
The answer is 142.41.
142.41. That's equal to 1 mole. So then we take 34.50 divided by 142.14.
It's about 0.2427.
0.2427, and that is moles of the magnesium acetate. 4 significant digits, 4 significant digits. Good. The next one tells us molecules. So we know we're using Avogadro's number, 6.02 times 10 to the 23rd. 6.5 moles. Every 1 mole is 6.02 times 10 to the 23rd molecules. Again, when doing scientific notation, we got to use this, 6.5 times 10, times 6.02 times 10 to the 23rd. It's going to be 3.913, 2 significant digits. It's going to be 3.9 times 10 to the 24th molecules. Six. How many grams does 7.5 moles of strontium carbonate weigh? We have 7.5 moles. We got to look up strontium carbonate. So strontium is 87.62. 87.62 plus 12.01 plus 3 times 16.
It's 147.63.
Every 1 mole of that is 147.63 grams of strontium carbonate. 7.5 times 147.63.
It's 1,107.225.
1,107 is going to round to 1,100 grams. 2 significant digits. How many grams would 170 molecules be? This is going to be very, very light because that's not very many molecules at all. Since we have molecules to word there, we know it's 6.02 times 10 to the 23rd molecules for every 1 mole. And every 1 mole of water weighs 18.02 grams. So 170 times 6.02 times 10 to the 23rd. Actually, it's divided by 6.02. It's on the bottom. 10 to the 23rd times 18.02. That's a very small mass, negative 21st, right? So it's two significant digits, 5.1 times 10 to the negative 21st grams. It's a very small fraction of a gram. The last thing on there besides percents and moles to grams, grams to moles, atoms to moles is the empirical formula. So if you recall, basically you've got to find a number that is divisible by all of the, can divide all of these. Looks like for this one, it's going to be 2. 2 can divide 12 into 6, 22 into 11, and 14 into 7. These can be no longer divided. So this right here is the empirical formula of C12H22O14. C5H10, where both of those can be divided by 5. So you get CH2. The empirical formula is this. C8H18, well, each of those can be divided by 2, C4H9. Here's the thing. These cannot be divided anymore. So this is the empirical formula of this. This would also be the empirical formula of itself because it can't be divided anymore. This has its own empirical formula, which is itself. There are many compounds that have the same empirical formula. It is just a ratio of atoms, and it's the most reduced whole number ratio of elements to other elements in the compound. So that's the mole empirical review. Don't forget, tomorrow is the test. So if you have any questions, by all means, drop in the Zoom tomorrow. But that's how we work through the problems in the review.